What's up, data pipeliners? In today's episode of Writing Data Pipelines with Kedro, we're going to be finishing up the series How I Write Pipes. The way that we're going to be finishing it is by adding chronocoding to our pipeline. And what chronocoding is it allows you to save state between pipeline runs so that we can resume the job that was done by the previous pipeline in the case of any errors that happened during the parallel processing. So let's go ahead and get started. So this was our pipeline that we had before. We have our params of the start date and the end date going into the generate date range, which would create a date range for us that we could then use to download. So these are the target date ranges for our downloading. It would pass that target date range set into the parallel get temp data function, which would then, in parallel, download all of those different dates. And then finally, once it would finish downloading, it would push it into the parallel choose station function, which then filtered the stations and then gave us our downloaded station data. Again, it's not connected to our average temperature by hour because the average temperature by hour function does not yet support the dictionary that comes back via the downloaded station data. So we need to modify the average temp by hour function in order for that to work. For now, the first thing that we're going to be focusing on is the chronocoding. So the chronocoding is going to happen here in this parallel get temp data function. When you're running any sort of operations that talk with external systems, such as a web API, that web API can fail, your network can fail, something can go wrong in the chain of command. But we don't want to interrupt the pipeline when we do get an error. So that's why we have error handling. However, we still need to get the data eventually. And so what this chronocoding allows us to do is it allows us to make our parallel get temp data an idempotent process. What this looks like in practice is you'll have a set of data that we've already downloaded, and there's going to be a missing set. So then when we rerun the pipeline, the missing set will get filled in. And then once the missing set get filled in and all the data is filled in, when you rerun the pipeline again, nothing happens. And so that's really important. Nothing happens, which means that we can rerun the pipeline as often as we would like, and there's going to be no changes in state. And so this is what we call idempotency. Okay, let's go ahead and start creating a chronocoding dataset for this parallel get temp data. So here we have our parallel get temp data, and we are already doing our error handling here. And then we're returning this date and data. So what we want to do with this is we want to create a list of dates that have already been downloaded, and we want to save and overwrite that list. The reason why we use chronocoding here is because normally Kedro does not allow a operation such as this, where you read a data set and then write back to the same data set. Kedro wants to avoid creating these cycles inside of the graph. However, when you really think about it, a dataset in the past and a dataset in the future, these are actually two different datasets, right? We're going to be reading from the dataset and then writing to effectively a future dataset, which will be read in the future. And so this is why I call it chronocoding, because there's a temporal separation between the reading and the writing. And so as a result, you're not actually breaking your DAG rules because you're adding in a new dimension for the graph to take advantage of. So in order to create a chronocoded dataset, it's very easy. The convention that I've kind of follow is I add in the dataset. So let's say already downloaded dates. So this will be our target dataset. And then to chronocode it, I add an exclamation point. So this is very similar to the Ruby syntax convention, where adding an exclamation point shows that you're modifying the state of the class that you're calling the function on. And notice here it points to the same file again. But this extra exclamation point allows you to then write back to the file. So this is chronocoding. Now you might be thinking, this will actually double the amount of datasets that I have, and that's absolutely correct. You're going to have to double your datasets. But when you use something like Kedro Wings, you'll be able to automatically generate these datasets based on your dataset name. And so if you take a look at our video on chronocoding with Kedro Wings, you can see how this process is actually super easy using that library. So now that we have our already downloaded dates and already downloaded dates Chronocoded dataset, let's add them to the pipeline. So here for this parallel get temp data, we're going to add another parameter for the already downloaded dates, and we're going to return a new set of downloaded dates. So now we're returning a brand new dictionary, and we're taking in a new dictionary of already downloaded dates. And so the already downloaded dates is going to be a dictionary that contains the date as the key and then true as the value. And so for any data that we download, we're going to be using that data, and any data that we had previously downloaded, we're going to be using that data. And so what we're doing is just taking the keys, which are the dates from both of these dictionaries, passing that in, and then returning that value as true. Now, if you'll notice here, PyCharm is kind of getting upset with me. It says here that the expected type was dictionary, but we got a tuple, and that's because of our type signature here. And so again, highly recommend you use PyCharm so that you get to take advantage of such features. And so let's go ahead and add the correct type. It's just going to be a tuple, dictionary, and dictionary. And now what we're going to do next is we're going to string it up in the pipeline. Here I'm going to be using already downloaded dates, and then the Chronocoded version of already downloaded dates, and this should work just fine. So now we have our already downloaded dates being passed into the function and passed out of the function. Let's make sure that we actually use it. So right here inside of this mapping function, we're doing this get temp data. What we need to do is we need to pass this already downloaded dates into this function so that we can check if the current date that we are about to process is or is not already downloaded. So we can do that very simply. So the way that I'm doing it is I'm using the get function on the already downloaded dates dictionary, trying to get the date that is in question, and if we don't get the date, we return a default value of false. And now when we have this default value of false, it'll go through and do the download if the date doesn't exist. But if the date does exist, then we're going to skip, and we're going to log that as a skip. The interesting part here is that we're going to be returning a blank statement. So actually what happens is that we return a none by default if you don't have anything in this return statement. And so as a result, this is going to break our dictionary convention. So what we need to do is we need to filter out all of the variables that are none from the downloaded data. Okay, so let's go ahead and give this guy a run. And hopefully there were no errors. And so we did run into an error, and this is something that I forgot. We need to actually create the JSON file for the very first run. So what's happening is the Chronocoding is looking for that particular file, but because we've never run the pipeline before, it doesn't exist. So we need to create an initial file in order for that to work. And inside of that initial file, we need to make sure that it has a valid JSON dictionary. So we just add our curly braces to there. So rerunning the pipeline should work. And there it goes. It started to download. Now taking a look at the actual visualization here, with the previous pipeline, we had nothing around our parallel get temp data. And now with the Chronocoded pipeline, we have these two data sets, already downloaded dates and the already downloaded dates Chronocode data set. And so these guys are feeding in to the parallel get temp data function to filter the dates that have already been downloaded. So if we go back here, we can see that the pipeline ran. We already have our choose station. And if we reopen our already downloaded dates JSON file, we see the populated dates that have been downloaded. So when we rerun the pipeline, instead of it trying to download this data, as we can see it doing here, where it says start download, finish download, it's going to instead skip those downloads. So let's rerun here. And there it goes, skip download, skip download. And so, because we're skipping downloads, we're not actually returning any data for the choose temp data function to run. So we're actually not getting any chosen, we're not going to be choosing any of the data here. If we were to remove some of these guys, let's just say some of these are false, then when we rerun one more time, we're going to see that we're not skipping those, but we are starting those downloads. And here we're re-downloading for those particular days. So this is how Chronocoding can be applied properly. All right, so that just about wraps it up for today's video. And in fact, I would like to see how you guys parallelize this average temp by hour function. I'll go ahead and put this code on a GitHub repository so that you guys can download, take a look, play around with it, and then I want to see what you guys have in store for this average temp by hour function. Make sure that you button that like, subscribe, and ring that ding if you want to know when we are pipelining. And I'll see you guys next time. Take care. Bye-bye.